team, we're now ready for section 2.1, algebraic and graphical solutions to linear equations. So let's review some of the terms that you probably learned in Algebra 2. The first one is the x-intercept, the point where the graph touches or crosses the x-axis. And we've talked about that in a previous section where you have the x-coordinate, but your y is always 0. We may also call this the horizontal intercept, because again, they may not always use x as the input variable. We also have something called the 0. The 0 is the x value where the function value is 0. Well, keep in mind that the function value is f of x, which also equals our y. You may see where we're going here. The third item here is the solution to a function value set equal to 0 is both the x-coordinate of the x-intercept and the 0. In other words, all three of these are solved the same way. So here's our first example using x-intercept, 0, and function values. Suppose they give us the function f of x equals 3x plus 2. Notice it's linear, but that doesn't really matter. They're asking us to solve for f of x equals 0. Since f of x equals 0, we can plug 0 in for f of x, in other words, our y value. 0 equals 3x plus 2, and solve this linear equation. Subtract 2 from both sides, and then divide both sides by 3. We get an x value of -2/3. Second, they ask us to find the x-intercept. Well, again, remember the x-intercept, we find the x value when our y is 0. Guess what we're going to do? Draw a little line there. We're going to plug in 0 for our y. Subtract 2 from both sides, and then divide both sides by 3. We get the x value of -2/3. Guess what? When they ask us to find the 0 of the function, that is when f of x equals 0. So we don't even have to do all of that again. We've already found it. We know x is a -2/3. Why are we showing you this? Because they may ask for any of those three things, and they're all the same thing. The x-coordinate of the x-intercept. Where does the graph hit that horizontal axis? So as a reminder, let's do some examples of solving various types of linear equations. In number 2, it's a little complicated. You got a lot of stuff going on the left, a lot of stuff going on the right. Let's recall how to simplify these. Let's distribute the 2 on the left and get 2x minus 6 plus 5 equals, now we also have a 3x and a 6x that can be combined on the right-hand side. That gives us a 9x minus 9. Notice we haven't added or subtracted anything to both sides of the equal sign. We can also combine like terms here on the left. That will give us a 2x minus 1 equals a 9x minus 9. And if our goal is to just get x by itself, we can do that. Let's subtract 2x from both sides. So that will give us a 7x here. And add 9 to both sides. -1 plus 9 gives us an 8. Divide both sides by 7, and we get x equals 8/7. Be careful. A common mistake I see is people just moving the numbers over and not doing the opposite operation. So if you tend to make careless errors in your work, and we all do on occasion, then write your steps. Show that you're doing the opposite. This should equal 0. We get -1 equals 7x minus 9. Adding 9 to both sides, and we get 8 equals 7x. Just like we did before. So if you're tired of getting all those little minute points taken off because of careless errors, Write it out. It doesn't impress me that you don't write it out one way or the other, so write it out for yourself. Example number 3, you may notice that we have some fractions going on. A lot of people do not like fractions, so let's get rid of them. We've got a denominator of 5 and 3. Remember, fractions represent division. The opposite of division is multiplication. So we're going to multiply by the least common denominator, which in this case is 15. So everybody's going to get distributed a 15. So everybody is getting multiplied by a 15. Why? Because those denominators will divide in. 5 goes into 15 3 times, and 3 divides into 15 5 times. So when we simplify, we no longer have fractions to deal with. So again, let's simplify the left separately. Combine our like terms on the left. And now let's get the x terms on one side and the constants on the other. I'm going to add 3x to both sides. And then now subtract 90 from both sides. And now divide both sides by -2. And we get x equals 57. In example 4, we still have an equation, but it's not linear, but that's okay. We are just solving for h, which is a linear term. So we need to get rid of everybody else on this right-hand side except for h. You notice there's a fraction, so we can multiply both sides by the least common denominator, which would be 3. We would get 3v equals 3 times 1/3 is just 1. In case you're not sure what we did, we multiplied the left by 3 and the right by 3. So that's why that denominator reduced. There's no plus or minus sign, so we're not distributing that 3 to anything else. But we want to get that h by itself. So since everything on the right-hand side is being multiplied, we're going to undo that and divide. So divide the right by pi r squared and the left of the equal sign by pi r squared. And we get h equals 3v divided by pi r squared. So we talked about solving linear equations algebraically, but now they want us to do it graphically. This is where zeros and the function value equaling 0 being the same thing as the x-intercept, this is where those come into play, is in the graphing part. So in example number 5, they're wanting us to solve by setting equal to 0. And then I'm going to add something here, okay? Graph and find the x-intercept. So let's take a look at that equation. 2x plus 5 equals 6x minus 7. And normally we would get the x's on one side, the constants on the other, but they're asking us to solve by setting it equal to 0. So let's move the 6x to the left. That gives us a -4x. Let's add the 7 to the left. That gives us plus 12 equals 0. Okay. So now what we're going to do is we're going to switch over to your graphing calculator. And we're going to plug in the equation y equals -4x plus 12 and look for the x-intercept. In other words, what value of x gives us a y value of 0? So let's plug in our equation, which was a -4x plus 12. And if we were to graph it, we still have an old window up, but that's okay. We're looking for the x-intercept, which is right here. It looks like a 3, but let's double check. And we know if we solved it algebraically, we would get a 3. But here's how we can find it. See the word calc up here above trace? We can hit second function calculate, and look, we can find a certain value, the 0, which is the x-intercept, minimum, maximums, and etc. So let's go down to 0, hit enter. Now, we know roughly where the 0 is because we know a 0 is where the x-intercept is. So down here, it says left bound with a question mark. So we want to move our cursor, you see that cursor right there, to the left of the x-intercept, and we're going to hit enter. And then notice it changes to right bound question mark. So we're going to move that cursor to the right side of that x-intercept right there and hit enter, as long as it's on the right. So notice it gives us kind of, on my calculator anyway, it gives us these two lines. On yours, it may just give these two arrows pointing inwards. And basically that's saying, so you want us to find that x-intercept in this interval. Because remember, not all equations are lines. There could be 7 x-intercepts. So you're going to tell it which one you want it to find. Notice here it's changed to guess question mark, and we said yes. So we're going to go down here to enter. Yes, we want you to guess. And then they will tell us the 0 is at x equals 3. And of course, we know the 0 is at the x-intercept, therefore the y is 0. So we found the x-intercept to be at 3, 0, therefore x equals 3. Now keep in mind, I know you guys can do these algebraically. You've been doing them since Algebra 1, even pre-algebra. The point of doing it graphically is to get you used to the vocabulary and understanding what does it mean when I'm looking for the solutions to these equations in one variable. On example 6, we're also going to be using our calculator, but with a different method. Instead of setting it equal to 0, we're going to be using what they call the intersection method. So we're going to take the left side of the equal sign, and let's call that equation 1, y1 equals 2x plus 5. And then the right side of that equal sign and set that equal to y sub 2, the 6x minus 7. And then pull out your calculator, and we're going to graph both of these. So let's input our two equations. We had 2x plus 5 as our first equation and 6x minus 7 as our second equation. Let's go ahead to Window. Actually, let's go to Zoom and change it back to a Zoom standard. That's number 6. That's just the negative 10 by 10 window. There we go. And they have graphed both equations. Well, if we want to find out the x value or those two are equal, we want the intersection. Notice the intersection is not in our window, but it is up here somewhere in the first quadrant. So let's go back to our window. And if we want in the first quadrant, we can make our x min 0, our x max can stay at 10, but our y has to be larger. So let's scroll down on the y. We can start at 0, but maybe go up to 20. I think they cross by then based on what we saw. And our hash marks can stay in 1. So let's go back up to the graph. And hey, look, there it has intercepted. So if we want to find that intersection point, we can either trace and try to kind of guess where they meet, or we can use the calculate once again. So go to second function, calculate, and see the word intersect. That means where the two lines cross, hit enter. And we're going to have the same idea as left bound and right bound, but this time they're asking us about the first curve. Look and see where your cursor is. Mine's colored, yours may just be in black and gray, that's fine, but look to see which line the cursor's on. And first curve, they're just saying, you know, kind of estimate where that intersection is. Because again, if those two equations aren't lines, they may hit in a couple of places. So I'm estimating the first curve to be somewhere around there, enter. Second curve on the red, same idea, it's around there somewhere. I'm going to hit enter and then guess, yes. And hey, look, they intersect at x equals 3 and y equals 11. So x equals 3 is our solution. Now, our last example is a modeling example. Number 7, the monthly profit from producing and selling guitar capos. If you don't play guitar, it's a little tool that you put on the neck across the strings to change the key. And it's modeled by the function p of x equals 10x minus 3,200, where x is the number of capos produced and sold. So again, we have x is the number of capos and p being the profit. So A is asking us how many capos must they produce and sell, okay? So how many, again, they're asking us to find x in order to make a profit of 6,225. So they're giving us P. Remember, to solve these, they have to be asking you for one of the variables and giving you enough information for all the others. So let's plug in that $6,225 for the P of x equals 10x minus 3,200. We're going to add the 3,200 to both sides. That will give us 9,425 equals 10x. Divide both sides by 10. We get x equals 942.5 capos. Now, here's something that I want you guys to learn, especially those of you that are going to be going on to like a business calculus course. Can you sell 942.5 capos? No, we can't produce and sell half a capo. Now, I know normally if we were to round, that is a decimal of 0.5, so 5 or higher, you would round up. But even if it was 942.03, you would still round up, because at 0.3, you would have to sell that many to make a profit. You want to be sure that you're making that profit. Believe me, your boss would rather you make more money than less money. So if that's your goal, you have to sell one more capo. So that means the company must produce and sell 943 capos to make a profit of $6,225. Always double check in your homework. I mean, technically you need to round up, but if for some reason they're accepting the 942.5, plug it in there. But just for future reference, if you are in business, round up. The second question is, how much must they sell to break even? Again, you will learn this later in a business calculus course, but the break-even point is the point where you're making neither a profit nor a loss. If a profit, if it's positive, you're making money. If it's negative, you're making a loss. So what's the only number that's neither positive or negative? 0. So again, that's kind of where those intercepts and zeros come in. So if our profit is exactly $0, no profit, no loss, equals 10x minus 3,200. Add the 3,200 to both sides, equals 10x. And when we divide by 10, we get an x equals 320. The company must produce and sell 320 capos to break even. Then it says, what is the least number of capos they must sell to avoid a loss? Well, if it takes 320 capos to break even, technically breaking even is avoiding a loss. So what I would say, the company must sell 320 capos to avoid a loss and 321 capos to make a profit. All right, guys, I hope that helped. Nice little review, actually, for solving linear equations and some graphing. And if you have any questions, contact me or your instructor. That's what we're here for. Talk to you soon. Bye.